So, hi students, today we are going with the first chapter of chemistry, that is matter in our surroundings. Now, before that, let us know what do we mean by matter. Start matter in our surroundings. So, first thing comes to our mind is the definition of matter. So, what do we mean by matter? So, to define matter, we need to have two properties. What are these two properties? It should have some amount of weight, or to be precise, we'll call this as mass. It should have some mass. Then the second thing which we do, it should occupy some space. Fine. Space means the term in scientific terms, space is called as volume. So anything which is has and occupies space will be considered under mass plus volume. They together makes a matter. So anything around you like book, table, chair, okay, your phone, your laptop, anything which is considered to be, these are all characteristics of matter because they occupy some space. Even the air inside the balloon, it occupies space. Okay, so that is also in which category? You can't see it, but still it is under which category? It is coming under the category of matter. Fine, but anything like hatred, affection, these all are feelings. I don't These are feelings. You can't see them. So these are not in category of matter. Substance. Now what do you mean by substance? Substance means any type of particles which cannot be separated by physical methods. Now what are physical methods of separation? Methods of separation. So fine, anything like hand picking, winnowing, which you can do easily. Winnowing, and physical processes are involved in separation, they come under this type. So anything which cannot be separated by any kind of these type of processes like filtration, these are physical processes of separation, that will be coming under which category? That will be coming under a substance. Characteristics of matter. So when you look at your table, there are no holes. No holes means you call it as continuous. Actually, if I call it as continuous, I am saying it is strong. Any kind of matter is not into a continuous category. It is coming under which category? It is discontinuous. Okay, now why discontinuous? Because it is made up of very tiny particles, very tiny particles, and but it appears to us to be continuous. Your table, book, chair, and is appearing to be continuous. You're not able to see the holes because they're made up of very tiny particles, and they are not, you know visible to our eyes, are not sensitive enough. Okay, so we are not able to visualize the discontinuity. So to us it appears to be continuous, but exactly it is discontinuous. So these particles which constitute matter are called either atoms or molecules. Fine. Now what is an atom and what is a molecule? Atom is the smallest particle of an matter actually, but each atom cannot exist independently. Cannot exist independently. Okay, they are generally the noble gases which can exist independently, but in general, atoms cannot exist independently. So they combine in a fixed ratio. Atoms combine in a fixed ratio with same type or a different type of ratio, same type, or it can be different type of atoms to form what we call it as molecule. Now for example, right, hydrogen. So what do you mean by hydrogen? Hydrogen will be represented as H2. H2 means what? So this is a molecule, H2 molecule, and it is made up of which type of atoms? Same type of atoms. Fine. I write ozone. Ozone means O3. This is a way to represent molecule, and it is again made up of same type. But similarly, if I write water, water will be written as H2O. Now it is made up of different type of atoms. Okay. Now the question arises: how do we know, or how can I prove that made up of small particles? So for this, we did a small experiment. Now, what is that experiment? Supposing I took a beaker, and this beaker is filled with 10 ml of some ink. You can do it at home, and 90 ml of water. So when we will add ink, what will happen? The color of the beaker will be dark. Supposing I took blue ink, so it will be blue, dark blue. Now what I did in the first step, I took 10 ml of this water and 90 ml of fresh water. Okay, this solution and 10 ml. Now what will happen after mixing? This color will be a slightly lighter blue. Again, I repeat it. Right now, I'll get a slightly lighter blue. Fine. Now I'll keep on repeating 5 to 6 times. So still I will get a very light blue color. What does this mean? This means supposing matter, this ink is made up of very large particles. Large particles means supposing in 10 ml there were 10 particles. 10 particles means on doing the experiment first time, it may be possible that it will transfer only 5 atoms. In the third time, it will be possible for only 2 atoms or 2 particles. In the fourth time, 1, and fifth and sixth, I should have no particle, and that means there should be no color. But supposing it is made up of a tiny particle, so 10 ml may contain 100 particles. Now 100 means first experiment there 50 transfer, in the next time 20 transfer, fourth time 10 transfer, fifth time maybe 5 transfer, sixth time 2 particles are transferred, so there will be still color. Similarly, more smaller particles means 10 ml might contain 1000. 1000 means 500 first time, second time this way, then there's another time, then 50, then 20, so still color. So if you keep on decreasing the size of the particles, the number of particles in the ink will be more. So more particles means what? More particle means what? There will be more color. So this proves, or maybe after 8 or 9 time of dilution, again I will correct color. So this means what? Matter is made up of very tiny particles. Matter is not continuous, it is made up of particles, and these particles are called as atoms, and they're constant. So now the question arises that are these particles stable, or they're continuously moving? So actually it was experimented and found fine that they're continuously moving. But again, because our eyes are not sensitive enough to visualize this movement, we see them as not moving. So this movement was seen by Robert Brown, so we call it as the Brownian movement. Now I can prove this point very easily. So see, but you are sitting in a dark room and there is a beam of light coming. So when this beam of light is there, there are certain particles, dust particles. Fine. Now, if you see these dust particles, you might have seen these dust particles are randomly moving in various directions. Now, why are they moving? Again, this movement, random movement, is only called as Brownian movement. Or so you can just check what is happening is this particle is getting attracted by this particle. So there is a force of attraction between the particles, which is calling it fine. This force of attraction is called as cohesive force. Then this is experiment of your Brownian movement. Another way of to prove my point that particles are not stable, they are continuously moving. Do with one more experiment, like they are sitting in a corner of a room, and supposing there is hot food kept over here. So what happens? Or you can say there you are using an incense stick over here, or you are using a perfume on this side. fine, and you are sitting at the other corner of the house. You can still feel the smell. You can feel the smell. How is it possible? How is it possible? Now again, the particles, the smell particles are getting, they are moving. They are moving and they are mixing with air, and they are traveling from this corner of this room to you, and that's why you are able to feel the smell. If they are stable, if they are not moving, so obviously you will not be able to feel the smell or the other corner of the room. Another way of representing this is take a this vessel and put some sugar in this, put water and add sugar, and observe after maybe 2 hours or something, you will see without stirring the sugar will get dissolved. Now again, why it is getting dissolved? Because sugar particles are continuously moving, and due to this movement, what is happening? The particle gets mixed with water and you will get the sugar solution to be sweet. Fine. If they are stable, then this mixing will not be happening. So this intermixing of particles due to Brownian movement is called as diffusion. This process is called as diffusion. Fine. Then again, a question arises in everyone's mind: if particles are continuously moving, then why why isn't my book getting dissociated or diffused inside the table? The reason for this is there, we call it as rate of diffusion. Fine. So what happens? A book is not getting diffused in the table is because the rate of diffusion of solid thing is very low. It may take years. That is the reason fossils are found in years. Fine, because then only the dead body and the soil get mixed. The alloying is formed in years, so it takes years to do diffusion in case of solids. Then it is in case of solid and liquid. That's why sugar took 2 hours or 3 hours to happen. Then it is in the case of liquid, and liquid ink got dissolved without stirring, but it may take around 2 minutes. And it is fastest in the case of gas and gas. So that's why smell particles were able to reach you, because they got diffused in the air very instantly, and in 30 seconds you're able to feel the smell. Fine. Besides, I can say the next property of diffusion is diffusion increases with temperature. Now, what do you mean by increase? How can I prove this point? Now, see, take sugar, take water, again heat it. Now, without heating, sugar and water, without heating, to dissolve sugar and water, it may take around, you can say, 2 hours. It will get diffused, but it will be slower. And if you put sugar and water and you heat it, so maybe it will take 2 minutes and it will get dissolved. This proves what? That diffusion increases, rate of diffusion increases with temperature. Fine. We experience smell of hot food. Again, what is the reason? The same reason. What happens is, basically, why does it happen? And why? The reason is, I take from law of conservation of energy. Law of conservation of energy. Now, what do you mean by law of conservation of energy? Energy can neither be created nor destroyed. It is transferred from one form to the other. So, and water, and this is at 25 degrees Celsius. Now, this will have certain amount of energy. So, when I heat it, there will be transfer of energy. So now this will become sugar plus water, and it will have more energy. Okay, now where is this energy going? This energy is going to the particles, and particles are moving. So anything which is moving has which type of energy? That is Kinetic energy, kinetic energy is half mv square. So when you supply energy, that energy will be converted to which form? Energy that will be given in which form? That will increase energy. Energy in which form? Heat form. Heat form means you are increasing the temperature. So what will increase? Kinetic energy will increase. What is kinetic energy? Half mv square. Now m is constant, so who is the variable? V is the variable. So who will increase? Velocity will increase. Velocity will increase means particles will start moving faster. Now, if they move faster, what will happen? Rate of diffusion will increase. That is the reason you get the smell of hot food, or when you burn an instant stick, you get the smell faster. Process the intermixing of particles is called as diffusion, and that is the reason why we get the smell from one corner of the room to the other corner. Then the particles have forces which is called as cohesive forces. Then comes rigidity and fluids. Way of classification of of matter is based on its fluidity. Fine. So we have two categories: rigid and fluid. Fluid means which can flow, you know, and they are stable. You can't change their shape, fine, but they can flow easily, like gases and liquids. They come into this category, and that's why we call them as fluids, because they can flow. And whereas solids are quite stable, they cannot flow, so we come under which category? Rigid part. So that's it for today. We'll continue in the next class. Thank you.